So the one thing that an interval scale is lacking is that true zero. So this 0 here is not a true 0. And if it was a true 0, you couldn't go minus, right? Because if it was really 0 temperature, you can't go less than 0 temperature. So when we get that true 0, that's when you get the most powerful scales. That's when you can do the most things with it. So for example, one thing that you can't do with this scale are things like ratios. So let's say that we had a Canadian who uses the Celsius scale, and we had an American who uses the Fahrenheit scale, and they were reminiscing about that autumn day that they spent in that in that vineyard, and that warm spring day that they spent in the field. So they're reminiscing, and they say, "Oh well, do you remember that time that we went into that vineyard in autumn, and then we went into that field in spring? You know, the average temperature there was 20 degrees Celsius." And the American would say, "Oh yeah, I remember that. The average temperature was actually 68 degrees Fahrenheit, but we both agree that's the same amount, right? 20 degrees Fahrenheit, 20 degrees Celsius, 68 degrees Fahrenheit. It's the same amount. We're in agreement. We know that we're measuring that actual true value." If the conversation continues and the Canadian goes, "Wow," he goes, "remember that spring day, 30 degrees Celsius, and that autumn day, 10 degrees Celsius, man, that spring day was 3 times hotter," right? Because 3 times 10 is 30. So it might say, "Yeah, that spring day, 3 times hotter than that fall day. Could you believe that?" And the American goes, whoa, wait a second. That autumn day was 50. The spring day was 85. That's not 3 times hotter. That's only 70% hotter, right?" And the Canadian would be like, no. It's not 70% hotter. It's 200% hotter, right? Because 30 is 200% more than 10. And the American would say, no, you're doing your math wrong. You're not getting to the heart of the matter. It was only 70% hotter. And the Canadian would say, "What are you talking about? 10 and 30, totally different. 200% hotter." And you can go back and forth on this over and over and over again. And they will never come to an agreement because they're using their scales wrong. So notice they came to an agreement on the average because you're allowed to do that in the scales. They could not come to an agreement on the ratios because you cannot do that in an interval scale. You want to do ratios, you got to go to a ratio scale. So a ratio scale, most powerful one we got. Categories are different, just like every other scale. Can rank the categories in order, just like the ordinal and interval scales. Intervals between categories are constant, just like the interval scale. It's got one more thing. There is an absolute 0. That's the last piece that we need for the ratio scale. And once you have that absolute 0, you can do all the math you want. So what do we mean by absolute 0? Well, in this case, we'll first say what is not an absolute 0. And a not absolute 0 is when you basically just choose an arbitrary 0. So for example, there is 0 on the Fahrenheit scale. And Fahrenheit, the inventor of the Fahrenheit scale, decided to put his 0 right there. He was making a temperature scale, and he said, "I'm going to put my 0 right there." Celsius, when he was making his scale, said, "You know what, I'm going to put my 0 right there." So does anybody know why Celsius chose that point for 0? That's where water freezes. So Celsius literally said, "I need a 0 point for my scale, and I'm just going to choose where water freezes." And that's why Canadians use Celsius, because that is at least as cold as it needs to be before you can go play hockey on the pond. So that's the one that we use. At least that's the reason I like to think we use it. Anyways, so he chose water freezing. Any idea what this one is? And this might be an urban legend, so you might want to fact check me on this. Apparently, Fahrenheit was developing his scale for refrigerator manufacturers, And that 0 is the temperature at which your ice cream turns rock solid, so it'll break your wrist when you try to scoop it out. So above that, your ice cream will be scoopable. Below that, your ice cream freezes. So that 0 was chosen there as the one where ice cream freezes. So you can double check that fact. It might be an urban legend, but I'm going to go with it. But importantly, both of these are arbitrary, right? You might as well say, oh, well, I'm going to choose at 0 when I feel comfortable in a room. So I'm going to choose 70 degrees Fahrenheit. I'm making a new scale. That's my new 0 right there. If you can do that, it's arbitrary. And once you do that, you don't have a ratio scale. So we do have a ratio scale for temperature. And the reason for that is because there is an actual true 0 for temperature. So once again, as I mentioned, temperature is basically the speed, the average speed of your molecules in your environment. So when it's hot, they're moving a lot. When it's cold, they start to slow down. They start to slow down a little bit. And there comes a point where they can't slow down anymore and they just stop. That's as cold as they can get. That is, you cannot get colder. You cannot get less motion than no motion, right? So there is an actual absolute 0 for temperature. And when Kelvin, there he is, when Kelvin came up with his scale, he said, all right, I'm not going to choose an arbitrary 0. I'm going to choose the real 0. And the 0 that I choose is an absolute 0 amount of temperature. So when all of those molecules and particles stop, that's as low as you can go. So 0 on the Kelvin scale is your absolute, not arbitrary, not artificially chosen, your real 0. 0 on this scale is actually 0 in the real world true temperature scale. So I should have moved these way over there into the other room because absolute 0 is phenomenal. Well, I mean, you can see here, it's like beyond minus 450 degrees Fahrenheit. So you can imagine, you don't want to go outside when it's like minus 30. Multiply that by, 15, and you'll get to here. So anyways, that's absolute 0. And when you are working with scales, such as Fahrenheit and Celsius, which are interval scales, it makes no sense to do ratios. But when you're working with the Kelvin scale, now you can do ratios. So now you can say that 70 degrees Kelvin is actually 40% warmer, 40% hotter than 50 degrees. You can say that 60 degrees is 20% hotter than 50 degrees, and you'll be correct. You will be true. It'll reflect the actual true measures of temperature because now we have an absolute 0. All right, so that is the ratio scale. And examples of the ratio scale, things like Kelvin is on a ratio scale. In psychology, things like reaction time are on a ratio scale. So if you want to measure people's reaction times and you flash a light, and then you see how quickly they can press a button, there's an absolute 0 for that, right? If they were instantaneous, then as soon as the light flashed, they could press the button. That's the 0. It's not arbitrary. They don't say, well, we're going to start counting 5 seconds after the light flashes. No, when the light flashes is 0. That's not arbitrary. It's an absolute 0. It makes it a ratio scale. Physical measures, things like height, right? Height has an absolute 0. The floor is your absolute 0 for height. Nobody in the world ever says, you know what, I'm going to measure my height. I'm going to start at my knee and just measure up. And that's going to be my new height. Nobody says they're going to choose their knee as absolute 0. I know a lot of us that are trying to get healthier and might be looking to lose some weight. Nobody can say, you know what, I feel like resetting the 0 on my scale. I'm going to set the 0 at minus 10. So what used to be minus 10 is my new 0. And lo and behold, I'm 5 pounds lighter than I was before. If you understand that as gaining 5 pounds, well, there you go. Anyways, so physical measures have absolute 0s. One thing that I will mention right here that's very important to remember when you're evaluating different measurement scales is that you always start at the bottom thing that can be done, and you go higher and higher until you figure out what category you're at. And the reason you need to do that is because there are certain scales that have an absolute zero, but they don't have, for example, intervals between the categories are constant, right? So you can get an absolute zero without constant intervals between them. So for example, in a movie rating system, you can have a zero quality movie, right? So a movie that's just, I don't know, a blank screen for an hour and a half. You can say that's a zero quality movie. And most people would say, yeah, that's absolute zero in terms of movie quality. But that doesn't all of a sudden mean that your movie quality ratings is on a ratio scale, because they're still missing this one. So they need to have everything in order to be a ratio scale. And sometimes there's an absolute zero without this, and people mistakenly say, oh, there's an absolute zero, it's a ratio scale because that's what it's known for. Not the case. You need all four of those before you end up with a ratio scale. And the maths that you can do with this, well, you can do ordering, you can do averages, and now for the first time, you can do ratios. Basically, all the math opens up to you in this case. All right, so those are the 4 different types of measurement. And again, as psychologists, we're trying to get to the truth. We're trying to get to these true scores. As psychologists, all we have access to are these measured scores. So it's very important to identify what measurement scale you have, because if you do certain things with certain scales, it might look like you're getting to the truth, but you'll be missing the actual true scores. So if you take averages with an interval scale, you're fine. If you take averages with an ordinal scale, you could be vastly misrepresenting what the true scores are. So it's always important as critical thinkers to think to ourselves, is it a nominal scale, ordinal scale, interval scale, or ratio scale? And depending upon what scale they are the researchers using these scales correctly? All right, so any questions on that? Yep.
I might just be overthinking this,
Mm-hmm.
but so like for Fahrenheit and Celsius, are they only interval scales because like there's no absolute zero?
Yes.
Because like what if you had a conversion factor where you could like make them the same? Would that still be considered interval? Because there's technically no true zero? I think I was overthinking it.
You might be overthinking it. If you convert these scales so that they have a true zero, like an absolute zero, a real zero, then basically they'll just be scaled version of the Kelvin scale,
Okay.
right? So you could definitely convert Fahrenheit into a scale with a true zero, and that's what we see right here. So minus, 467 Fahrenheit is actually zero. But you can't do math with the scores from a Fahrenheit scale because the real zero is being represented by minus 467. If the real zero is being represented by zero on your measurement scale, then you have an absolute zero, you have a true zero. So they come close, right? Because they do have those equal intervals, but they're missing that true zero. All right, any other questions, comments about the measurement scales? All right, so that is what I wanted to cover for today.